All right, AP, this is sample exercise 3.60. We're determining empirical and molecular formulas. So determine the empirical and molecular formulas for a compound that gives the following percentages upon analysis in mass percent. So these are the data that you are going to be calculating yourself during a mass percent problem. But if you're given mass percents by the problem, you're going to be asked for the empirical formula or the molecular formula. So the molar mass is known to be 98.96 grams per mole. Go and press pause now, because here come the solutions. First, we convert the mass percents to masses in grams. In the 100.00 in 100.00 grams of this compound, there are 71.65 grams of chlorine, 24.27 grams of carbon, and 4.07 grams of hydrogen. Now, we're going to use these numbers. You'll notice that the percentages of each element has just been turned into a gram. That's why we choose to assume a 100-gram sample. You can assume any size sample, any mass sample, and the same percentages of the compound due to each element are going to be the same. Remember, that's due to the law of definite proportions, also known as the law of constant composition. So when we assume a 100-gram sample, what we do is we get this really nifty, convenient thing that we can do is we can simply change that percent sign into a gram unit. It makes it very, very simple for us. So once we've done that, we use these masses to compute the moles of atom present in this sample. If there's 71.65 grams of chlorine, we can use the molar mass of chlorine to calculate how many moles of chlorine that is. If we have 24.27 grams of carbon, we can use the molar mass of carbon to compute how many moles of carbon that is. Similarly, if we have 4.07 grams of hydrogen, we can use the molar mass of hydrogen to calculate how many moles of hydrogen that is. So with these values, we are going to evaluate, look at them real quick, and we're going to pick which mole value is the absolute smallest. You see that these two right here, the moles of chlorine and moles of carbon, are tied for the absolute smallest. So now we have our smallest value, and we are going to divide each of these three values by that smallest value. So dividing each mole value by 2.021, again, it's the smallest number of moles present, we obtain the empirical formula. So what happens is we divide, get my pen out here, if we do in fact go through and divide each of these values by that 2.021, this is going to end up being 1, 1, 2. Okay, whole numbers. We're going to take these whole numbers, and these will become, as you can see here, the subscripts for the empirical formula. Now, once we have the empirical formula, it's ClCH2. To determine the molecular formula, we must compare the empirical formula mass with the molar mass. By adding up all the masses of these constituent elements, 1 chlorine, 1 carbon, 2 hydrogens, we find that the empirical formula mass is 49.48 grams per mole. Now you should double check this. We've done this in another sample exercise, so I won't go through that right now. We also know that the molar mass is known to be 98.96 grams per mole. How do we know that? It was given to us by the question. We're simply going to take the molar mass of the empirical formula. We are going to divide the molar mass by that mass. And so we're going to take the 98.96 grams per mole divided by 49.48 grams per mole, and notice that we get a very, very whole number. And so we take our empirical formula. In order to find the molecular formula, we take our empirical formula and we multiply every subscript in the empirical formula by 2. So that gives us Cl2, C2, H4. So this substance is composed of molecules with the formula Cl2, C2, H4. Notice that the method we employ here allows us to determine the molecular formula of the compound, but not its structural formula. The compound Cl2C2H4 is called dichloroethane. There are 2 forms of this compound shown in the figure below. The form on the right used to be used as an additive in gasoline. And so notice the number of each type of atom is still the same, but they're simply bonded to different atoms. Remember, that changes the substance's properties. So when we draw structural formulas, especially stick and dash drawings, it's very important that we keep our structural formulas in check.